Good morning, all. Am I audible? Guys, do let me know in the comment section. Am I audible? Yeah. Sudha Priya. Good morning. Okay. As I already suggested, live class போகும்போது கரெக்டாக நான் லாஸ்ட் மினிட் நான் எந்த செகண்டில் ட்ராவல் பண்ணிட்டு இருக்கனோ அதே செகண்டில் நீங்களும் ட்ராவல் பண்ணணும் such that we will be in live stream. Otherwise, the communication between you guys and me will automatically get lagged. So try to be with me. So travel along with me in the same time where I am traveling. So yes, we are in DC theorem. Yesterday we have been solved some problems based on Theorems, right? Today also we are going to do the same thing. So we will increase the number of questions today and let us try to bring the answer. உங்களுக்கு நான் என்னென்ன மெத்தட்ல டீச் பண்ணணும் apply the all methods properly. See, one more suggestion, you can also go ahead with your own methods. நான் ஏற்கனவே சஜஷன் கொடுத்துருக்கிறது, if you want to get எந்த எக்ஸாம்ல நீங்க பெட்டரா ஸ்கோர் பண்ணணும் அப்படின்னாலும் you should try to develop your own methods. But ultimately, whatever the things that I am giving here, that all are my own way only. By my experience, I got those things. By practice, slowly, when speed will increase, automatically you all guys will get something better than me, and you have to apply it. Problem solve பண்ணும்போது be conscious, right? Just to follow the things whatever that I am telling you today. First, face on the serious வச்சுக்காதீங்க. Always be smile. It's a kind of small trick in order to be energetic. When your face is smile, your brain also will be active. And second thing, be conscious. தேவையில்லாம ஒரு கொஸ்டினுக்கு வந்து 2 மினிட்ஸ்ல சால்வ் பண்ணணும் அப்படிங்கறது ஆன்சர் இருக்கும்போது நீங்க என்ன பண்ணுவீங்கன்னா கொஞ்ச நேரம் கொஸ்டினை பத்தி யோசிக்கிறது, கொஞ்ச நேரம் அதர் திங்ஸை பத்தி யோசிக்கிறது. These kind of things you must avoid. Okay. And third thing, while solving the problem, if you don't know the concept, blindly skip that question. Later, by spending some time on Google or on YouTube, somewhere with your friends or textbook, you can analyze why you are unable to get the answer for that particular question. How you have to analyze? You have to check whether you are aware of the particular concept. If you don't know the concept, then first should try to learn the concept, then again come back to the question, solve it. If you are very well aware of the concept, but you are unable to solve the question, then put the solution whatever that you are getting. Apply the concept, apply the formula, try to bring the solution. Till you are not getting the answer, then compare your solution with some other people solution or resources, whatever that you want to do. Okay, this is the way you have to properly learn any concept. Fine, sir. So let us start up with the first question. So I think this is the question which I had given yesterday to solve, right? Now you can take this question again, try to solve the answer. I don't know how many of you have been dropped the answer in the group. Now drop the answer in the comment section. Let me cross check. Take 2 to 3 minutes once again. First, find out the VTH value, then find the value of RTH. Do it fast. For something you can use the paper, for something you can use your brain. I don't think calc is required here. I told you avoid using calc more than 95%. So there will be very necessity, sir. Without calc I can't solve these values. In that case, you can give priority to use calc. Otherwise, please don't touch the calculator. Use your brain, use your papers, try to solve it and drop the answer. Third thing, do it fastly, step by step when you are solving. Be conscious and try to solve it as fast as possible. That is very important. Such that speed of process will also helping you to improve your speed performance in a conscious way. You will be on the track. So take this question once again, solve as speed as possible and then drop your answer in the comment section. Do it fast. Do it first. Anyone got the answer for the question? Suhaina and Mori, good morning. What other people are doing? Answer please. Okay, your time is over. Let me try to solve the question. Okay, listen to the question first. Actually, we are we are supposed to find out the value of VTH and RTH, right? How will you calculate the value of VTH? What is the procedure to calculate the value of VTH? So to calculate the value of VTH, step number one, we have to identify the load terminal. Yes. So load terminal is clearly defined as X and Y. Identified. Step number two, remove the load across the load terminal if it is there. If load is available here, then we can remove, but it is already removed by the questioner. So I don't want to do that. It is already readily available. Step number three, find the potential difference of the load terminal or voltage across the load terminal. That is known as Thevenin voltage, or we can also call it as open circuit voltage across the load terminal. Both are same only. So that is what we are going to do now. Now if you look at the question carefully, so let me remove this unwanted stories. Yes. Take the same question. So what we are going to do now? So we have to find out the voltage across X and Y, right? Yes, sir. So can I say the voltage drop across this 1 kilo ohm resistor is known as Thevenin voltage? Any doubts? Good. So good morning. VTH equal to 0.5, RTH equal to 200. Good. So voltage drop across the 1 kilo ohm resistor is equal to Thevenin voltage. Can I say like that? Of course, that is true only, sir. If you observe between this node and the Thevenin node, is there any load? No. If there will be no load, then you can treat these 2 points as a single point. Similarly, you can do this here also. In between these two nodes, there is no person. So you can treat these two nodes as a single node. Conclusion is the voltage drop across this 1 kilo ohm resistor is known as the Thevenin voltage. We can call it as Thevenin voltage, or we can call it as open circuit voltage. Chalo. So now our target is, our focus, our intention, our attention, everything is just we need to find out the voltage drop across the 1 kilo ohm resistor by using the given data. Fine, sir. Next, what can we do with this? If you observe, the Thevenin node is always open circuited node. When a node is open circuit, then resistance offered by that node will be, that branch will be approaching infinity. When resistance approaching infinity, current I can be written as V by R. Since R is approaching infinity, so V by R will approach 0 ampere. So the conclusion is current flow through this open circuited branch is always 0 ampere. So now I am going to select this node once again. I would like to apply nodal. While applying nodal analysis, it is same like our previous model, right? Yes, let us see. So here, if I will, when I am trying to apply the nodal, suppose let me take this node voltage is Vp. We all know nodal will supply the current through the entire branch. And we are naming it as I1, I2, I3. While applying nodal, step number 1, what we have to do? We have to apply Krichov Current Law. So when you are applying Krichov Current Law, see, according to nodal analysis, all the currents always going outward. None of the current will come inside. So algebraic sum of outgoing current will be equal to algebraic sum of incoming current. But while applying nodal, there will be no incoming current. Now, how will you write the expression for I1? I1 is the current flow through the 3xy dependent source, and then this current I1 will get, after reaching this node, what will happen to the current I1? Whether it will be splitted or it will be diverted through the 1 kilo ohm resistor. Now you have to observe carefully. What will happen here, sir? Since this branch is open circuited, so current will not go. So whatever the current that is coming through this dependent source, 3Vxy dependent source, that current I1 is getting diverted through the value of 1 kilo ohm resistor. So till this point, same current will flow. Next, from this the conclusion is, what we have understand is, the value of this 3Vxy and this 1 kilo ohm resistor both are connected in series. And I told you, in series we can interchange the position of the elements. How we can interchange? So they had given one dependent source with a resistor like this. And this resistor is connected with the ground. If you observe the circuit carefully, this point is considered as ground point in the circuit. So ground voltage is 0 voltage. Here the potential, that is common point, its voltage is 0. So from here the resistance value is, we know, that is 1 kilo ohm. Here we have the value of 0 voltage, and here we have plus minus 3 times of Vxy. And at this node exactly we are considering the current voltage value as Vp. Fine, sir, no issues. Next, actually we are supplying the, according to nodal, current I1 is going like this, yes. Now how will you write the expression? I told you, in series circuit we can interchange the position of the elements. It does not affect the circuit property. So how you can redraw this circuit is, interchange the position of voltage source and resistor, such that you can avoid the confusion. And without interchanging the polarity, plus minus 3 times of Vxy, and here the resistance value is 1 kilo ohm, and here we are having the voltage value is Vp. Fine, sir. Now we know current is, I1 current is going like this. Now how will you write the expression for I1? I1, if you want to know the current flow through this entire branch, we have to identify the voltage drop across this 1 kilo ohm resistor. How will you identify that? We know, see, nodal, according to nodal, Vp is higher than all other potentials. So if you observe here, positive terminal of the dependent source is connected in the terminal of the resistor. Here we have Vp. So the potential difference can be written as Vp minus 3 times of Vxy. This is the voltage drop across the resistor. If I will divide it by the value of resistor, that is the value of current I1. We got the expression for current I1. Let me substitute here. So this can be written as Vp minus 3 times of Vxy upon 1 kilo ohm. So I can write simply 1k. Kilo ohm means 1000, we know. Now let us write the expression for current I2. Current I2 is the current flowing through the second branch. If you observe here, we have a 2 kilo ohm resistor, then it is directly connected with the ground. How will you write the expression? For this, expression can be written as potential difference Vp minus 0. This is the voltage drop across the resistor, divided by 2 kilo ohm. This is the current flow. Vp by 2 kilo ohm is the current flow through the 2 kilo ohm resistor. Now let us write the expression for I3. If you observe I3 carefully, how I3 will look like? Let me draw the resistor. I3, current I3 is having 2 kilo ohm resistor, and it is connected with a supply source voltage plus minus, and this one is connected with the ground. This voltage is 5 and the positive plate is connected with the resistor terminal. Here we have Vp. Current is flowing in this way. This is I3. How will you write the expression for I3 now? I3 can be written as, first we have to find out the voltage drop across the resistor. For that, I am finding the potential difference between the terminals of the resistor Vp minus 5. If you divide it by resistance 2K, that is the current flow through the 2 kilo ohm resistor or in that entire series branch. So I can say this value is Vp minus 5 upon 2 times of K equal to 0. Now in order to make the common denominator value, see here denominator is 2K, here denominator is 2K, but here it is 1K. In order to make it common, I am multiplying numerator and denominator by 2. Such that what will happen? 2 into 1K will become 2K. Now we can directly add all the numerators because denominator has been producing common value. Now we can rewrite this expression as 2 times of Vp minus 2 into 3, 6 times of Vxy, just to multiply it by 2. Then we will have Vp, we are having Vp minus 5 common value. Whole divided by what will you get? Whole divided by, you will get twice of K equal to 0. If you pass this 2K to the right side, 0 into 2K will become 0. Now see there, 2 Vp, Vp will give you 4 times of Vp. Will give us 4 times of Vp. Minus 6 times of Vxy. Minus 6 times of Vsy. Minus 5 equal to 0. Let us go to the next page. So finally what we got here is 4 times of Vp minus 6 times of Vxy minus 5 equal to 0. Or this can be written as 4 times of Vp minus 6 times of Vxy equal to 5. Let us treat this one as equation number 1. Now here what we have to understand is, sir, we have two unknowns. How do I identify the value of Vp or Vxy? If you observe the circuit carefully, நான் ஏற்கனவே சொல்லியிருந்தேன் இல்லையா, Vxy அப்படிங்கிறது இந்த சர்க்யூட்ல வேற எங்க இருக்குன்னு பார்க்கணும். Because அது வந்து ஒரு dependent source. That dependent source can be controlled with the help of some other terminals. If you observe the given circuit carefully, let me remove all this unwanted data because we have been solved this question. Come back. Sir, if you observe, this is Vxy. What is this? This terminal name also they have been defined as Vxy. So if you observe the potential difference between x and y, that can be simply written as Vxy. The potential difference that we are measuring across x and y is called Vxy. That is known as what? Our Thevenin voltage. That is known as what? Open circuit voltage. So the conclusion is Vxy and Thevenin voltage both are same only. First conclusion. And the second conclusion is, when I was applying the nodal, I have written that this current is considered as I1. This current is going like this, going like this, going like this. This is the current I1. Yes, sir. Now, how will you write the voltage drop across this 1 kilo ohm resistor? There are two ways. Either you can write current through the 1 kilo ohm resistor into value of the resistor. This will also be written as, we know this is called what? Thevenin voltage, or this can also be written as Vxy, or this can also be written as open circuit voltage, because voltage drop across the 1 kilo ohm resistor is going to be our Thevenin voltage. This is the conclusion. We got the relation now. Let us substitute this value into the equation. Come back to the next equation. You know, from this what we have understood, Vxy is nothing but Thevenin voltage, Vth. Next conclusion. So directly what we can put here, in place of Vxy we can directly put our Thevenin voltage. And the next conclusion is, we have to bring the relation between, at this point while applying nodal I kept the voltage as Vp. Right? Yes, sir. So this I1, current I1 can also be written in alternative way. How will you write? I was writing this expression as Vp minus 3 times of Vxy divided by 1 kilo ohm. This is also correct only. Current flow through that branch can also be written as Vp minus 3xy divided by 1k. That is how we are writing this expression. From this, let us match up this equation with this equation. Just now we figure it out. What we found from this expression, I can say 1k into I equal to Vth. Am I right, sir? Yes. Similar, from this I can write I is equal to VTH by 1K. Yes. So finally, you can replace this I by VTH by 1K. Shall I write like this? VTH divided by 1K equal to VP minus 3 times of VTH divided by 1K. 1K getting cancelled out. If you bring this minus 3 VTH to the left hand side, it will become plus 3 VTH. Plus 3 VTH plus 1 VTH. Already one more. So total it will become 4 times of VTH will be equal to VP. So VP can be replaced by 4 times of VTH. I told you, நம்ம nodal apply பண்ணதுக்கு அப்புறம் என்ன பண்ணனும்? You have to write all the expression in terms of நமக்கு என்ன வேணுமோ அதுல எழுதிக்கணும் நம்ம. So finally what we found, this VP can be replaced by 4 times of VTH. Just now we figure it out. So let me substitute here such that it will become 4 into 4 times of VTH minus 6 times of VTH equal to 5. 4 into 4 will become 16 times of VTH minus 6 times of VTH equal to 5. 16 minus 6 will become 10 times of VTH equal to 5. From this, VTH equal to 5 upon 10, or I can say it will be equal to 0.5 voltage. Finally, we got the conclusion. Now tell me, did I apply any new concept here? No. How I got the answer? By simply applying Thevenin and nodal. The concept is, I told you, 95% of the question can be simply cracked with the help of normal KCL, KVL, nodal, Ohm's law. Sufficient. If you are very strong in those 4, you will be able to crack the all type of question. Fine, sir. So we got the answer. Finally, come back to the question. Let me remove all the data now. Unwanted stories. So what we know now is we got the answer for the first question. The value of Thevenin voltage can be written as 0.5 voltage. Let us put it in a box. This is over. Let us keep our attention with the RTH. So in order to calculate the value of RTH, I told you to do what? Yes, as usual, you can follow the procedure. Sir, one more thing. When your circuit is having both a dependent and independent source, there is one more method. Circuit la நம்ம இன்னொரு மெத்தடையும் அப்ளை பண்ணி ஆன்சர் கொண்டு வரலாம். எப்படி கொண்டு வரலாம் அப்படினா, see listen. Actually நான் என்ன பண்ணிருப்பேன் அப்படினா, yesterday I taught you one procedure to calculate the value of RTH. நம்ம external source கனெக்ட் பண்ணி அதுக்கு அப்புறம் nearest ல இருக்க நோட் சூஸ் பண்ணி nodal analysis apply பண்ணி ஆன்சர் கொண்டு வரோம் இல்லையா? That is one procedure. There will be one more procedure. This procedure you can apply when your circuit is having both a dependent and independent source. If your circuit is having both dependent plus independent source, ரெண்டுமே கொடுக்கறோம் இருந்து சர்க்யூட் கொடுத்திருந்தாங்க அப்படினா அந்த மாதிரி சர்க்யூட் வரும்போது ப்ரொசீஜர்ல நீங்க வந்து இந்த ப்ரொசீஜர் அப்ளை பண்ணிக்கலாம். என்ன அப்படினா, லோடுக்கு அக்ராஸா ஃபர்ஸ்ட் ஓபன் சர்க்யூட் வோல்டேஜ் கால்குலேட் பண்ணிட்டு நெக்ஸ்ட் லோட ஷார்ட் சர்க்யூட் பண்ணி அந்த ஷார்ட் சர்க்யூட் கரண்ட்டை நீங்க கால்குலேட் பண்ணணும். That is one more procedure. Now what I am going to do is I will apply this procedure. நீங்க என்ன பண்றீங்க அப்படினா, you should apply our normal procedure. Yesterday சொன்னேன் இல்லையா, across the load connect the external source, or otherwise I will do one thing. For this question let me prove it in both way. எப்படி போட்டாலும் ஒரே ஆன்சர் தான் வரும் அப்படிங்கறத நான் ப்ரூவ் பண்ணி காட்டுறேன். But don't forget, this method is applicable only when your circuit will be having both dependent and independent source. If you observe, this given question is having both independent and dependent source. So the method that I am telling here can be applicable for the above circuit. Shall we proceed? Yes. Already we have been identified the value of open circuit voltage, that is 0.5. Now what we need to know is short circuit current. Of course we are also calling it as Norton current. Load oda terminals நீங்க short circuit பண்ணிட்டு அந்த இடத்துல current calculate பண்ணீங்கன்னா, see, if you short circuit these two, இந்த junction short circuit பண்ணிட்டு இது வழியா போற current calculate பண்ணீங்கன்னா, this is called short circuit current. We are also calling it as Norton current. Okay, Norton, அடுத்து Norton theorem இருக்கு இல்லையா? Norton theoremத்துல யூசுவலா நம்ம என்ன பண்ணுவோம் அப்படினா, Thevenin theoremத்துல லோடுக்கு அக்ராஸா இருக்க வோல்டேஜை கண்டுபிடிப்போம். Norton theoremத்துல இத ஷார்ட் பண்ணிட்டு கரண்ட்டை கண்டுபிடிப்போம். That is the difference. ரெசிஸ்டன்ஸ் கால்குலேஷன்ல எந்த டிஃபரன்ஸும் கிடையாது. Theveninல நம்ம என்ன பண்றோமோ அதே தான் Nortonஸ்லயும். Only difference is here we are finding open circuit voltage, there you will be finding short circuit current. That's all. Proceed பண்ணலாமா? Now if you observe the circuit carefully, I am shorting the terminal of X and Y. அப்ப இதை ஷார்ட் சர்க்யூட் பண்ணிட்டீங்க அப்படின்னா see usually நம்ம என்ன பண்ணுவோம் Vxy is known as the potential difference between X and Y. So this can be written as Vx minus Vy generally. This is how you are finding the potential difference between the terminal. But now when you are short circuiting, இப்ப நம்ம என்ன பண்ணிருக்கோம் X and Y terminal are getting short circuited. அப்படின்னா meaning என்ன? If you observe between X and Y, we don't have any elements. So what we can say? We can say the voltage Vx will become equal to the value of Vy in this short circuit. So I can replace Vy by Vx or you can replace Vx by Vy. Both are same. Resultant value will be 0. So the conclusion is when I am trying to find out the short circuit current in this circuit, the value of Vxy is approaching 0 voltage. First conclusion. Next. அப்போ சர்க்யூட் எடுத்துக்கிட்டு வேற எங்கெங்கெல்லாம் Vxy இருக்கோ அதுக்கு எல்லாத்துக்கும் நீங்க 0 voltage போட்டுக்கலாம். Now if you observe the circuit carefully, see there. Here also we have Vxy. If I substitute 0 here, 3 into 0 will become 0 voltage. Voltage value 0 அப்படின்னா that can be short circuited. So this difference is also getting short circuited. Are you getting me? That is the beauty of the question. நான் என்ன பண்றேன் அப்படின்னா load ஓட terminals short circuit பண்ணிட்டேன். அப்ப அது வழியா போற கரண்ட்டை கால்குலேட் பண்ண ட்ரை பண்றேன். லோடோட டெர்மினலுக்கு ஒரு பேர் வச்சிருக்காங்க Vxy அப்படின்னு சொல்லிட்டு. அப்ப ஷார்ட் சர்க்யூட் பண்ணிட்டா Vxy ஓட வேல்யூ 0 ஆகுது. சர்க்யூட்ல வேற எங்கேயாச்சும் Vxy இருக்கான்னு பார்த்தா இருக்கு, அவங்களே கொடுத்திருக்காங்க. அப்ப அங்கேயே நான் 0 போட்டேன்னா வோல்டேஜ் வந்து 0 ஆகுது. வோல்டேஜ் 0னா தட் இஸ் ஷார்ட் சர்க்யூட். அப்ப நான் இந்த டிபெண்டன்ட் சோர்ஸையும் ஷார்ட் சர்க்யூட் பண்றேன். இன்னொரு விஷயம் நீங்க கேர்ஃபுல்லா அப்சர்வ் பண்ணீங்கன்னா see there. Here we have 1 kilo ohm resistor. Short circuit will be having 0 ohm resistor. Now tell me, suppose if there will be any current is coming like this. Let me redraw the circuit for your understanding. We have a battery here, DC voltage source. Then we have 2 kilo ohm resistor. Then here also we have 2 kilo ohm resistor. If you observe, dependent source is short circuited. That is, it will become useless now. Here we have 1 kilo ohm resistor. Carefully observe the circuit. 1 kilo ohm resistor. Here we have 2 kilo ohm resistor. But here we have short circuited current. Short circuit will have 0 ohm resistor. Now tell me the answer. Sir, current, adutha point. Next property of current I am introducing here. Basically, our current will have two mandatory points you have to remember about the current. One is, current will always flow from higher potential point to lower potential point. First point. Second, current will always choose the low impedance path. Current will always choose low impedance path. அப்படின்னா meaning என்ன? Let me prove it. Low impedance path. இதோட meaning என்ன? Sir, we all know, according to Ohm's law, I is equal to V by R. Yes. If you observe R or Z, you can keep Z also, common value, impedance. If I will increase the value of impedance in any branch, then current flow through that particular branch will decrease. Am I right? Yes. So we understood that current and impedance both are inversely proportional to each other. When impedance is approaching 0, what will happen to the current? Current will be approaching infinity. Yes or no? So what is the conclusion? If any branch will have 0 impedance, 0 ohm impedance. If any one branch will be having 0 ohm impedance, then that branch will consume maximum amount of current from the supply. Maximum amount of current from the supply. அப்ப என்ன ஆகும்? ரிமைனிங் இருக்க parallel branches. See, if you observe the given circuit carefully, நம்ம சர்க்யூட்ல பாத்தீங்கன்னா see we have 3. Sorry guys. Yeah. See, we have 3 parallel circuits. 2 kilo ohm resistor, 1 kilo ohm resistor, then 0 ohm resistor. அப்ப இந்த சப்ளைல இருந்து 5 voltage சப்ளைல இருந்து வந்துட்டு இருக்க கரண்ட் இந்த ஜங்ஷனை ரீச் பண்ணதுக்கு அப்புறம் எந்த பாத்தை சூஸ் பண்ணும்? கண்டிப்பா இந்த 2 kilo ohm வழியாவும் 1 kilo ohm வழியாவும் கரண்ட் flow இருக்காது. Why sir? Current always choose low impedance path. Already there is a short circuit. In that short circuit, resistance is very less. When resistance is approaching 0, current will be approaching infinity. Infinity means ideally it is infinity, but practically it will consume the maximum supply current from the supply. So these two branches will become useless now. Finally, this circuit can be redrawn as simply we have 5 voltage source and 2 kilo ohm resistor and this short circuit line. Now tell me what is the value of short circuit current. Finally, short circuit current will become simply equal to supply voltage, supply current supplied by the source. How will you find out this? So short circuit current equal to total supply voltage, 5 voltage. Total supply voltage divided by total resistance, 2 kilo ohm. 2 kilo ohm means 2000. So I can say it will be 2.5 milliampere. So the conclusion is 5 by 2 is 2.5. Kilo ohm millia marno. That is 10 power minus 3. So 2.5 milliampere. Conclusion is we found the value of short circuit current also. So we found the value of short circuit current equal to 2.5 milliampere. I told you how will you calculate the value of RTH now? Thevenin resistance is known as the ratio between open circuit voltage and short circuit current. Or we can also write this one. See, Thevenin voltage will be equal to open circuit voltage, right? Divided by short circuit current. We can write like this, or open circuit voltage. Open circuit voltage means Thevenin voltage, right? Divided by short circuit current means Norton current. So what is the conclusion? If you know the Thevenin voltage and Norton current, directly you can calculate the value of Thevenin resistance. Thevenin resistance will be equivalent to Norton resistance. Both are same. So the conclusion is, if you know the value of Thevenin voltage and Norton current, directly you can calculate the value of Norton resistance or Thevenin resistance. Just to remember this relation. Because sometimes in your examination they will give you Norton current, Thevenin voltage. You will be requested to calculate the value of RTH in small exams. Okay, fine. Calculate panlama. So the value of Thevenin voltage is 0.5 divided by value of short circuit current is 2.5 milli. Milli means 10 power minus 3. Once again, let us cancel it. It will become 1 by 5. So it will be 1 by 5. 10 power minus 3 மேல கொண்டு வந்தீங்கன்னா 10 power 3. So 1 by 5 will be 0.2 into 10 power 3. Or you can say it will be 200 ohm. So what is the conclusion? Thevenin voltage is 0.5. Norton current is 2.5 milliampere. Thevenin resistance or Norton resistance equal to 200 ohm. இப்போ நம்ம பார்த்த ப்ரொசீஜர் தான் நார்டன் கரண்ட்டை கால்குலேட் பண்றதுக்கான ப்ரொசீஜர், காமன் ப்ரொசீஜர். இதே ப்ரொசீஜர், இந்த ப்ரொசீஜர் அப்ளை பண்ணி தான் நீங்க நார்டன் கரண்ட்டை கால்குலேட் பண்ணணும் ஆக்சுவலா. ஓகேவா? Now as I promised that I will try to bring the answer with the help of another method also. Usually in our last class what we saw, this RTH can also be calculated with the help of another method. In our method நம்ம என்ன பண்ணுவோம்? Step number 1 to calculate the RTH, identify the load terminal. Okay. Step number 2, remove the load from the load terminal. Step number 3, deactivate all independent sources. Number circuit la one independent source irukku. If it is the voltage source, we have to short circuit. If it is the current source, then we have to open circuit. So I have to short circuit this voltage source in order to bring the answer. So let me short circuit this. Let me redraw such that you can understand. So short circuit voltage will be short circuited. Then we have a 2 kilo ohm resistor. Then here we have one dependent source. Here we have one more resistor. Here we have one more resistor. So circuit will be going like this. What we have to do next? We have to connect one external source with the value of VDC, and the current supplied by the external source is IDC. So your next target is we have to apply nodal by choosing the nearest node. Now you have to understand. நான் இப்போ என்ன பண்ண போறேன்னா இங்க டைரக்டா 3 VDC ன்னு போடுறேன். இது கரெக்ட்டா நீங்க யோசிச்சு ஆன்சர் சொல்லுங்க. அவசரப்படாம அது எப்படி சார் 3 VDC ஆ மாறுச்சுன்றது கரெக்ட்டா யோசிச்சு ஆன்சர் சொல்லுங்க. Learn this subject. Why I am putting VDC here? If you observe the circuit, X க்கும் Y க்கு நடுவுல என்ன வோல்டேஜ் இருக்கோ அதை தான் நம்ம இங்க சப்ஸ்டிட் பண்ணுவோம். பிகாஸ் அவங்க தான் சொல்லியிருக்காங்க இது ரெண்டுத்துக்கு நடுவுல என்ன வோல்டேஜ் இருக்கோ இங்க சப்ஸ்டிட் பண்ணிக்கோங்க. ஃபர்ஸ்ட் நான் சால்வ் பண்ணும்போது இதை VXY ன்னு சப்ஸ்டிட் பண்ணனா, அடுத்து நம்ம ஷார்ட் சர்க்யூட்ல ப்ராப்ளம் சால்வ் பண்ணால ஷார்ட் சர்க்யூட் கரண்ட்டுக்கு x யும் y யும் டெர்மினல் ஷார்ட் பண்ணீங்கன்னா இங்கேயும் வோல்டேஜ் 0 ஆகுதா? இப்போ பாருங்க x க்கும் y க்கும் அக்ராஸா VDC கனெக்ட் பண்றேன். அப்ப இங்கும் என்ன வரும்? Vxy equal to VDC. In this case Vxy will become equal to VDC because Vxy அப்படிங்கிறது voltage across the open circuited terminal x and y. So now we are connecting VDC across it. So I am putting VDC. Fine, sir. Next, if you observe, this 2 kilo ohm, 2 kilo ohm both are connected in parallel from here. The observation. நம்ம வந்து calculate பண்ற பாயிண்ட்ல இருந்து பாத்தீங்க அப்படின்னா ரெண்டு பேரும் parallel தான் இருக்காங்க. Right? Yes. So அப்ப 2 kilo ohm and 2 kilo ohm reduce பண்ணீங்க அப்படின்னா what you will get? How much you will get? That will become equal to 1 kilo ohm. So that circuit can be read on us. Let me go to the next page. One minute, guys. Yes. So now we are having 1 kilo ohm resistor, source, again we will be having VDC, current, IDC. I hope this is 1 kilo ohm. This is also 1 kilo ohm. This is plus minus 3 times of VDC. Let us cross check once. Yes, plus minus 3 times of VDC, 1 kilo ohm, 1 kilo ohm, VDC, IDC. இப்போ நம்ம என்ன பண்ணிக்கலாம்? Let us choose this nodal as usual. Apply nodal analysis in order to bring the answer. Start பண்ணலாமா? இப்போ இந்த நோட்ல இருக்க வோல்டேஜ் நான் டைரக்டா VDC எழுதலாமா பாருங்க. கரெக்ட் தானங்க? How, sir? If you observe this 1 kilo ohm and 3 this VDC branch both are connected in parallel. So same voltage will appear here also. Any doubt? No, same VDC will appear here. First conclusion. Next conclusion is if you observe at this node, in the node our voltage தான் இங்க வரப்போகுது. கரெக்ட்டா? Actually this is common node connected with the ground 0. Here we have 0. Here we have 0. So if you want to know the voltage at this node, what we have to do? We have to find the potential difference. Suppose let us take here எனக்கு Vx அப்படிங்கிற voltage இருக்குன்னு வச்சுக்கலாம். இங்க 0 இருக்கு. So how will you write? Vx minus 0 equal to VDC. Can I write like this? So the conclusion is I can say Vx equal to VDC. அப்ப இந்த ஜங்ஷன்ல இருக்க voltage பேர் வந்து VDC தான். Next, according to nodal analysis, selected node is the superior one that will going to deliver the current for the entire circuit. 1 minute. Let me remove this unwanted stories from here. Yes. Now let us take the circuit and do it. Fine. Apply பண்ணலாமா? There are 3 branches. 1, 2, 3. Let us take I1 as usual, I2, I3. So while applying nodal, step number 1, we have to apply Krichov Current Law. So I1 plus I2 plus I3 equal to 0. Now write the expression for I1. If you observe the circuit, I1 அப்படிங்கிறது current flow through the VDC. Already VDC the current வந்துட்டு இருக்கு. That value is IDC. But the direction is opposite to our nodal. I am putting minus. I2 can be written as VDC minus 0 divided by 1 kilo ohm. Can I write in this way? That is correct. I2 அப்படிங்கிறது current flow through the 1 kilo ohm resistor. How will you find out the voltage drop? By taking the potential difference between the terminal values of the 1 kilo ohm resistor. Terminals la enna irukku? VDC 0. For this 1 kilo ohm resistor, we have VDC here. Here we have 0 voltage. So VDC minus 0 will give you the voltage drop. Divided by 1 kilo ohm will give you the current flow. Next, I3. I3 எப்படி எழுதுவீங்க? If you observe, I3 is having a dependent source. And that value is plus minus 3 times of VDC. Then it is having a resistor. At last it is connected with the ground only, 0 voltage. Here we have 1 kilo ohm and this is the point where we have our VDC voltage. Current is going in this way, I3. Now you know you can, in series circuit we can interchange the position of the element. It will not affect the circuit property. So what I can do is, I can shift the interchange the position of the resistor and voltage source. This is 1 kilo ohm minus plus 3 times of VDC. It is connected with the ground. Now this negative terminal is connected across the resistor. So it will be minus 3 VDC. Here we have simply VDC. Now how will you write the expression for I3? So I3 can be written as VDC minus of minus 3 times of VDC whole divided by 1 kilo ohm resistor. Come back, and here we can write like this. So I am writing in the same way. 1 minute guys. Yes. So this can be written as VDC minus of minus will become plus 3 VDC upon 1K equal to 0. Finally, the conclusion is denominator is same. So we can add the numerator. VDC plus 3 VDC will become 4 VDC. 4 VDC plus VDC will become 5 times of VDC. 5 VDC by 1 kilo ohm equal to IDC. I am passing IDC to the right side such that it will become plus IDC. From this I can rewrite this. VDC divided by IDC equal to 1K means 1000 divided by 5. If I will cancel it, 2 times of 5 will become 10. So 200 ohm is the correct answer. I promised you that I prove you that in both cases we will get the same answer. இப்போ பாருங்க last case level answer வந்திருக்கு 200, இப்போ எவ்வளவு வந்திருக்கு same 200. Is there any difference? No. So when your circuit is having both dependent and independent source, either you can go up with this procedure or you can go up with the old procedure, like by finding open circuit voltage and short circuit current. Both will give you the same answer. Okay, I hope you got the complete conclusion about the question. That is method. Now take the next question. Try to bring the answer for this question. The given data for this question is we have 5 voltage. Here we have 5 ohm. Here we have 2.5 voltage, 2.5. Here we have, sorry, this is 2.5 ohm. Sorry guys, rows. ohm, 2.5 voltage, 2.5. Here the resistance value is 5 ohm. This is also 5 ohm. Now they told that this terminal is X, this is Y. As usual, calculate VTH and RTH. Do it fast. Take 2 to 3 minutes. Drop your answer in the comment section. Keep smile in your face. Be active. Be conscious. Drop your answer. Anyone got the answer? It is simple question, no? I mean, no dependent sources. Okay, try, bring the answer. Thevenin voltage and Thevenin resistance. Sugumari. Thevenin voltage is 5 by 3. Good. 5 by 3 means 2.333 voltage, right? Sorry, 1.666. 1.666. Any other answer? What other people are doing? Drop your answer, please. RTH equal to 2.5 ohm. Good. Nice. Sugumari. Good. Any other? Sure. Let me drop the answer. Rajesh 2.5 ohm. 2.5 voltage, Rajesh. RTH 2.5 ohm. Kalai. Hmm. Rajesh, whether that is voltage or resistance, you put VTH, right? Okay, fine. Let us continue. Let me drop the solution. Guys, listen. First, let us calculate the value of VTH. While calculating VTH, once again, if you observe, we are estimating the value of Thevenin resistance across X and Y. First conclusion. While calculating the value of the voltage across the X and Y, if you observe carefully, the voltage drop across the 5 ohm resistor is known as Vxy. Can I say like this? Both are same. These two nodes are same. These two nodes are same. So the conclusion is, I can say once again, Vxy equal to Thevenin voltage. We can also call it as open circuit voltage. Next, since this port is open, when the port is open, then resistance offered by the port will be approaching infinity and current will be approaching 0 ampere. So the conclusion is, through this open circuited terminal, there will be no current flow, it will be 0 ampere. Next conclusion. So if you observe the circuit, what I am going to do is, I am selecting this node and I am treating this voltage as Vp. I would like to apply nodal at this node. Shall we proceed? Yes. So let us apply nodal. According to the nodal, let me take, in this branch current is I1, downward it is I2, left side it is I3. So according to nodal, first we should apply KCL. We know while applying nodal, current won't come. Always current will go outside from the selected node. So algebraic sum of outgoing current will be equal to incoming current is always 0. Write the expression for I1. I1 is the current flow through the 2.5 ohm resistor. Now if you focus on the current I1, this current is going and then it is going through 2.5 voltage resistor, then it is going through 5 ohm resistor and then it is coming back. So there are three people in this branch. One is 2.5 ohm resistor, 2.5 voltage source and then 5 ohm resistor. How will you write the current then? Let me tell you. For your understanding, I am writing this. First we have 2.5 ohm resistor. Next we have a voltage like this. Next we have one more 5 ohm resistor. Then it is connected to ground, 0 voltage. This is 5 ohm resistor. This is 2.5 ohm resistor. As of now, in order to continue the derivation, what I am going to do is, we know these two resistors are connected in series. So 2.5 ohm plus 5 ohm will give you 7.5 ohm. First conclusion. Next, this voltage value is how much? 2.5 voltage. So this circuit can be redrawn like this: 7.5 voltage plus battery minus plus 2.5 voltage. I can connect like this. So it will be 2.5 voltage. This will be 7.5 ohm resistor. At this junction we have voltage VP. And here is the current I1 is going. Now you can write. See, here we have VP. Here we have minus 2.5. So this current can be written as, how will you write? Write the expression VP minus of minus 2.5 voltage whole divided by resistance is 7.5 ohm plus I2. How will you write the value of I2? I2 can be written as, I2 is the current flow through the 5 ohm resistor. It is connected to the ground, 0 voltage. So this can be simply written as VP minus 0 upon 5 ohm plus I3. I3 can be written as, can I write like this, VP minus positive plate voltage is connected. So VP minus 5 divided by 5 ohm equal to 0. Any mistake? No, sir. Now what is the common value? Here we have 7.5, here we have 5, here we have 5. I hope the common LCM is going to be 15. What I am going to do is, I am taking the numerator, I am multiplying it by 2. And the denominator also I am multiplying it by 2. Such that 2 times of 7.5 will become 15. So denominator value will become 15. Here I am taking numerator, I am multiplying it by 3. And I am taking denominator doing the same. Again here also I am taking numerator, multiplying it by 3. Denominator also will be multiplied by 3. Such that all the denominator value will become 15, common value. Now we can add the numerator directly. So numerator will become multiply. First two terms will be multiplied by 2. So it will become 2 times of VP. Minus of minus will be plus. 2 times of 2.5 will be 5. Then plus 3 times of VP. Again third one, 3 times of VP minus 3 times of 5 will be 15 equal to 0. So 3VP plus 3VP will become 5VP. 5 plus 3 will become 8 times of VP. 5 minus 15 will give you minus 10 equal to 0. From this I can say 3 times of VP equal to 10. Or I can say the value of VP equal to 10 by 3 voltage. So the conclusion is, value of VP at the selected node is 10 by 3 voltage. That is what we found. So let me, it is 10 by 3. So what we found is, at this node we have the voltage 10 by 3 and this is 5 ohm, this is 2.5 ohm, this voltage is 2.5 voltage. I hope this is 5 ohm, this is also 5 ohm, this voltage is 5 voltage. Am I right? I hope the data is correct. Yes. So now what we have to do? We have to find out the voltage across these two terminals. Yes sir, we have to find it. How will you do that? We know the voltage 10 by 3. Now how will you find out the current flow through this branch? For that, let me take this circuit. See, actually, and the one branch we have a voltage source. Then again we have a resistance. Right? Fine sir. For your better understanding, so here we have 2.5, here we have 5, here we have minus plus 2.5 voltage. And at this junction node we have 10 by 3 voltage, here we have 0 voltage. Fine sir. Now the 5 ohm voltage across the 5 ohm resistor is considered as Thevenin voltage. Am I right? Of course, I am correct. So first of all, for that, I would like to know the current flow through the entire branch. How will you identify that? So current can be written as, can I write like this? Just observe 10 by 3 minus of minus 2.5 voltage whole divided by 7.5. Is there any mistake in my conclusion? Of course, I am correct. Right? Yes, we know how to do this. So what I have done, just I found the potential difference between the potential. See, this already நம்ம பண்ணிருக்கோம் இல்லையா 2.5 5 ohm add பண்ணீங்கன்னா 7.5 resistance மாறிடும். அப்போ 7.5 then negative plate positive plate 2.5 voltage இங்க 10 by 3. Now apply 10 by 3 minus of minus 2.5 divided by 7.5 போட்டீங்கன்னா you will get the current. We know 10 by 3 will be 3.3333 plus 2.5 we have to add. If you add 2.5 you will get 5.8333 divided by, if you put 7.5, that will give you the current flow through that branch. It will be 0.7778 ampere. Now we can easily identify. See, there are so many ways. நீங்க voltage division apply பண்ணிக்கலாம் இல்ல வேற ஏதாச்சும் உங்களுக்கு ஐடியா தோணுனா அதே நீங்க apply பண்ணலாம். It is your choice. எனக்கு என்ன மைண்ட்ல தோணுதோ that is what I am applying here. So across the 5 ohm. Now we found the current flow through the branch. How will you find out the voltage drop across the 5 ohm? So Thevenin voltage can be written as current flow through the circuit into resistance value, because across the 5 ohm only we are calculating Thevenin. If you multiply this resultant current by 5, I am getting 3.8889 voltage. This is the correct answer what I am getting. Did any one of you got the same answer? You can just drop your answer here, right? If I did any mistake, you can correct it, no issues. Did any one of you got the answer? No one? Okay, fine. Anyway, I am getting 3.889. If there will be any mistakes, finally you can correct me. Fine, sir. How will you calculate the RTH? Since the given circuit is very simple circuit, it is very simple to identify the value of RTH. While calculating RTH, step number 1, identify the load terminal. Step number 2, remove the load from the load terminal. Step number 3, deactivate all independent sources. How will you deactivate? This source we have to short circuit, this source we have to short circuit. Then what will you do? See, if you observe, this 5 ohm, this 5 ohm both are in parallel. So the net value will become 2.5. Again, this 2.5, 2.5 will be in series. So, உங்களுக்கு என்ன வரும்னா 2.5, 2.5. மொத்தமா சேர்த்து 5 வரும் again. So, again 5, one more 5 is connected in parallel. So, the value of RTH calculation is very simple. We are getting 2.5 ohm as the answer for RTH. But VTH value is 3.889. See, if I did any calculation mistake, you can drop it in the comment section, right? Otherwise, we will go to the next question, right? Fine, sir. So this is all for this question. Next, I brought so many homework questions for you guys intentionally, such that you all get the grip with this subject. So in this circuit, let me drop the question first. This is 5 ohm resistor. This current is 5 ampere. This is plus minus 10 times of IP, current IP, they put name, and this is 5 ohm resistor again. So this is polarity, this is plus, this is minus, correct it. And here we have 5 ohm, here also we have 5 ohm, here we have 10 voltage source. Now same IP is flowing through this branch. The question is, what is the voltage at this node? They are asking us to find out the value of VP. VP oda value evalonu kekranga. Okay, please proceed and identify the value of VP. My question is, you please find the value of IP also. VP, IP rendithiyume find panni drop it in the comment section. VP equal to 10/8. Sorry, Gauri Muthu. Are you talking about the previous question or present one? VP, this one only, na? Gauri Muthu. For which question you are giving the answer? For this one? Fine. Drop the answer. No issues. Take your time. Do it fast. Drop the answer in the comment section. See, almost I taught you in a crystal clear manner how to apply Nodal, Ohm's law, KCL, KVL. Everything is fine. No sir, previous question la VP into pair vachana. Okay, here. Did I made any mistake in the calculation? Okay, let me cross check. You guys go up with the new question. இதை நான் cross check பண்ணிக்கிறேன். நீங்க புது question solve பண்ணுங்க. What you will get? VP minus 5 by 5. VP by 5. VP minus 2.5 divided by 7.5. No, it will be plus equal to 0. So it should be 2 VP. It will be 5. It will be 3. It is 15. It is 3. So 3, 3, 3. 8 VP. Minus 15. Here we have plus 5. Minus 10 equal to 0. What we have here? I'm getting 10 by 8 only. 10 by 8. Last time I put 10 by 3. Unknowingly I did this. 3 VP, 3 VP, 2 VP. 8 VP only. So this is 10 by 8 for the previous question. Not 10 by 3. Please correct it. If there is any numerical mistakes. 10 by 8 you can put and then follow the same procedure. No issues. Fine. Take this question. Find the value of VP and IP. Last question la edachi numerical value maati pottundana the correction panikonga. No issues. I know you all understand the procedure, right? You will get the answer there. You can go ahead with that. For this question, what is the answer? Did anyone got the value of VP and IP? No one? You can simply apply nodal now. I think that is sufficient. There is one step nodal apply you will get the relation between VP IP. Everything you can solve and get the answer. I don't know how many of you are solving. Sure. Let me solve the question. Listen. So I am just giving the clue. Just to select that node. VP அப்படிங்கிற node இருக்கு இல்லையா அதை select பண்ணி apply nodal. There are 4 branches. 1, 2. This current will come and it will go this way. So totally we have 4 branches. Chi star VP equal to 6. Good. So let me take current I1 here. Current I2 in the second branch, current I2 in the third branch, current I4 in the fourth branch. Listen, this node and this node, inga or node irukla, innor node irukla, rendume same node da. You can treat this to a single node, no difference. Now if you apply, there are 4 branches in that node. While applying nodal, all the current will go outward, we know. So I1 plus I2 plus I3 plus I4 equal to 0. Now, what is the expression for I1? I1 is the current flow through the 5 ohm and 10 voltage circuit. So, the total I1 can be written as VP minus 10 voltage divided by total resistance offered by the branch. Total on the circuit and the resistance and the branch resistance 10 5 ohm 5 ohm plus current I2. I2 can be written as VP minus of minus 10 IP. Hereafter you have to solve all this divided by 5 ohm plus I3. I3 already avanga kuduthitaanga 5 ampere, but the direction is opposite to our assumption. So I am reversing. I4 VP minus 0 divided by 5 ohm equal to 0. Am I right? This is I4. Last branch 5 ohm branch la pora current. Reduce pannunga. See inga 10 irukku. Here we have 5. Here we have 5. First in the rendu branch in the rendu term add pannunga because denominator same mark, such that what we will get VP minus 10 divided by 10 plus VP minus of minus will become plus, so it can be written as VP plus 10 times of IP plus 1 more VP whole divided by 5 common. Then that minus 5 irukku right side pass panina it will become plus 5. So when I am passing it to the right side, it will be plus 5. Now see there, in order to make the common value in the denominator, I am multiplying numerator and denominator by 2 such that once again we can add these two terms. So this can be written as Vp minus 10 plus, first of all, Vp plus Vp will become 2 times of Vp. 2 times of Vp into 2 will become 4 times of Vp. வெளியில ஒரு 2 இருக்கு இல்லையா? Then 20 times of IP, 10 IP into 2 whole divided by 10 equal to 5. Now we can pass this 10 to the right side. 5 into 10 will become 50. Now Vp plus 4 Vp will become 5 times of Vp plus 20 times of IP minus 10 equal to minus 10 equal to 50. Minus 10 right side pass panninga it will become plus 10. So at last 5 times of Vp plus 20 times of IP equal to 60. Treat this one as your equation number 1. Now we have to bring the relation between Vp and IP. எப்படி சார் கொண்டு வரதோ அதுக்கு listen. இப்போ நீங்க சர்க்யூட்டை கேர்ஃபுல்லா அப்சர்வ் பண்ணி பாத்தீங்க அப்படின்னா I1 அப்படிங்கிறது current flow through this branch. கரெக்ட் தானே? I2 அப்படிங்கிறது current flow through the second branch. The I2 அப்படிங்கிறது எப்படி flow ஆயிட்டு இருக்கு பாருங்க. I2 can be written as, right? 1 minute guys. I think I have to redraw the circuit. Or otherwise let me clean up. See. Let me clean this zone. Yes. It is too difficult sometimes to handle this pattern. Yes. So now if you focus the circuit carefully, how can we write the relation between IP and VP? எப்படி எல்லாம் ரிலேஷன் எழுதுனா போறீங்க? IP அப்படிங்கிறது current flow. எதுல போயிட்டு இருக்கு? இந்த 5 ohm branch resistor இருக்கு இல்லையா? இந்த branchல போயிட்டு இருக்க கரண்ட்டுக்கு பேரு தான் IP அப்படின்னு எழுதலாம். VP அப்படிங்கிறது இந்த நோட்ல இருக்க வோல்டேஜ். Similarly IP இங்கேயும் இருக்கு. Now how to bring the relation between these people? இவங்களுக்கு நம்ம எப்படி ரிலேஷன் வந்து கொண்டு வரலாம்? You have to think and bring the answer. Now the conclusion is, if you observe Vp, the I1 அப்படிங்கிற current வந்து நம்ம எப்படி எழுதிக்கலாம் அப்படின்னா I1 can be written as I1 equal to IP அப்படின்னு நம்ம எழுதலாம் first. Because இந்த branchல போற current வந்து nodal படி I1. ஆனா அவங்க கொடுத்திருக்க டேட்டா படி அது IP. So I1 equal to IP ன்னு எழுதலாம். I1 நீங்க எப்படி எழுதுவீங்க? Vp minus 10 voltage divided by 10 ohm எழுதலாமா? From this I can say IP equal to Vp minus 10 by 10 எழுதலாம். That's all. So the alternative is IP can also be written as Vp minus 10 divided by 10. So from this, if you reduce this, you will get 10 times of IP equal to Vp minus 10. So from this what we can say, if I will multiply it by 2 on both sides, it will become 20 times of IP equal to 2 times of Vp minus 20. Treat this one as your equation number 2. Now substitute equation number 2 in equation number 1. This 20 times of IP can be replaced by 2 Vp minus 20. அவ்வளவுதான். அப்ப என்ன வரும்? Finally 5 times of Vp minus 2 Vp minus 20. Correct na? Sorry, here we have plus. Plus 2 Vp minus 20. That is 20 IP can be replaced by 2 Vp minus 20. Equal to 60. Equal to 60. Now let us reduce this. 5 Vp plus 2 Vp will become 7 times of Vp. Minus 20 right side pass panna it will become 80. So the value of Vp will become, this is not 2. 5 plus 2 will become 7. So this is 7 times of Vp. It will be 80 divided by 7 volt. Am I right? You can, Vp is 12 voltage, IP equal to 1 ampere. Again I made the mistake. Guys, did I made mistake anywhere? Identify பண்ணுங்க. VP equal to 24.2877. What is the mistake? VP minus 10 by 10. VP minus 10 by 10. VP plus 10 IP by 5. Then minus 5 VP. Then VP minus 10. 2 VP. So VP minus 10. This has become 4 VP. 20 IP. No doubts. Next that will go there. 4 VP plus 5 VP. 20 IP. That will become 60. So 5 VP plus 20 IP will be 60 only. Then IP can be written as VP minus 10 by 10, no doubt. So from this 10 IP equal to VP minus 10, if I multiply by 2, it will become 20 IP equal to 2 VP minus 20. I think substitute pannina 2 VP, it will become 7 minus 20. I'm correct, no mistakes. My answer is correct only. So I didn't do any mistake. So VP equal to 80 by 7. Once we know the value of VP equal to 80 by 7, then we know 10 times of IP can be written as, or we can simply say IP equal to, how can we write? VP minus 10 divided by 10. That is the value of VP. Already we know. IP can be written as VP minus 10 by 10. So substitute it here. VP can be written as 80 by 7 minus 10 divided by 10. If we take LCM, it will become 80 minus 70 divided by 7 into 10 will become 70. So this can be written as 10 by 70, or we can say 1 by 7 ampere. That is the value of IP. So we got the value for both VP and IP. Okay, simple nodal, but just apply it carefully. Nothing is there. See, I just apply nodal only. I told you, no? That's all. Take the next question. Question is, this is the question. Let me drop the values. 6 ampere current source, 5 ohm resistor, 10 ohm resistor, as usual here, 10 ohm resistor, 10 ohm resistor. Again, voltage value is 16 voltage. Now they are calling it as terminal X and Y. We have to calculate the value of VTH, RTH. That's all across this. But அவங்க VTH மட்டும் தான் கேட்டிருக்காங்க. I need, எனக்கு VTH தேவை, Norton current, RTH. எல்லாமே calculate பண்ணுங்க. Do it by your own, right? I am not going to do this. IN அப்படினா என்ன? Norton current அப்படிங்கிறது short circuit current. X ஐயும் Y ஐயும் short circuit பண்ணீங்கன்னா இங்க வேல்யூ என்ன வரும் அப்படிங்கறத ஃபைண்ட் பண்ணிட்டு drop the answers in our group. Telegramல drop பண்ணுங்க. Okay? Let me go ahead with the next question. These all are homework question only, but they are very easy. 5 voltage. உங்களுக்கு எப்படி ஃபீல் ஆனாலும் நீங்க தான் சால்வ் பண்ணணும். யார்கிட்டயும் டிஸ்கஸ் பண்ணாதீங்க. குரூப்ல நீங்க ஆன்சரை மட்டும் தான் போடணும். Don't put the solution. This is R ohm load கொடுத்திருக்காங்க. Next 5 ohm. This is 2 ampere. Same. Calculate the value of VTH, then calculate the value of Norton current, then calculate the value of RTH. Okay, this is your task. Let me go ahead with the next question. Right. 1 minute. What they told is here, they told this voltage is 20. Here they had given the resistance value is 4 ohm. This resistance is R. This is minus J2 farad. Sorry, minus J2 ohm. Here they had given plus or minus 3 voltage. Okay, now the question is, so these two circuits are interconnected. Now question is, calculate the value of R in which maximum power is transferred from circuit A to circuit B. Okay, the question is, calculate the value of R. R value என்னவா இருந்தது அப்படினா maximum power will be transferred from circuit A to circuit B. In order to transform the maximum power from A to B, what can be the value of R? இங்க இருக்குல்ல இந்த branch ஓட இந்த resistorோட value என்ன இருக்குன்னு கேக்குறாங்க. Okay, that is the next question. Previous நான் கொடுத்த ரெண்டு கொஸ்டினையும் first homework எடுத்து try பண்ணுங்க. Then this is also Thevenin theorem only, but I need your attention with this Thevenin plus maximum power transfer theorem conditioning ஒரு time go through பண்ணுங்க. Go through பண்ணிட்டு apply that logic here. Logic apply பண்ணி answer வருதான்னு பாருங்க. After that, if you don't get the answer, then I will just let you know. In the next class, I will drop the answer. See, in the next class, we are going to solve the problems based on maximum power transfer theorem plus this one or two questions I will solve in the Thevenin. I am not going to solve, you have to solve because I have to see whether you guys improved in these methods or not. I hope now it is crystal clear how to apply Thevenin theorem, how to apply Norton. Maximum மட்டும் clear பண்ணிட்டீங்க அப்படின்னா DC will become very easy. Okay, as I already told you that superposition la inga question irukadu. AC la problem solve பண்ணும்போது I will merge both and I will teach you how to crack the question also. That is very easy. So this is all for today lecture. Answer மறக்காம solve பண்ணி group la drop பண்ணுங்க. You have to be active. எல்லாருமே problem வந்து solve பண்ணுங்க. Solve பண்ணிட்டு group la drop பண்ணுங்க. Okay? I will check. I will ask the people to check. So this is all for this lecture. Remaining